This is Self-Directed Research. James and Amos, our hosts, get really hyped about different things, and each week they take turns presenting their hot takes. This week's discussion didn't follow the slide deck completely, but it's available for your entertainment and curiosity nonetheless. Check it out at sdr-podcast.com/episodes to see the presentation for each topic, as well as the show notes and transcripts. New episodes are published every Wednesday. Once again, thank you to Ladybird web browser for sponsoring this episode. For more information, listen to the end of the episode and check out the description and our show notes. This week, Amos presents You Might Not Need ARC.
Hey everyone, Amos here. Just wanted to apologize for the audio quality of this episode. I had my gain set up too high. I was too far away from the mic. There was AC in the background. We had to get rid of echo. We had to get rid of clipping. You can hear that it's heavily processed. It was interesting, so we didn't want to throw away the episode or record it over again. It gets better in the next few episodes, so thanks for your patience. I hear you. I love you. Bye.
I'm digging the new slide format. You went very like a, what is it, American Psycho, eggshell and embossed print on us.
Oh, that's what the GIF was about.
Oh, yeah.
I didn't know how to interpret that. I was too scared to ask. It is one of the built-in Keynote themes. Now, you might be wondering, Amos, why are you using Keynote? Did you love Apple that much? No, but I do hate Google and its Slides product that doesn't let you paste any vector format in there. So you can't paste SVG. It prints an error about EPS, embedded PostScript, which I know what that is.
It's the other vector format.
I don't know what the fuck that's doing in their dialogue, but I know what that is. Yeah. So apparently there's like a 13-step workaround to still import vector things in Google Slides. And of course, everybody who wants to get stuff done just rasterizes it and gets a huge PNG in there instead. But I don't want my presentations to be like really large. I don't know.
Gotcha. Okay. I'm excited about this.
Cool. So should I just go? I'm going to share my screen, I suppose. Can't see y'all anymore. This is just a tiny laptop. Okay, I guess I will do this one blind. That's okay. Today I want to talk about ARC Mutex T and ways to avoid it. First off, James, how do you say Mutex? Do you say Mutex? Mutec?
I say Mutex.
You say Mutex.
Mu as in like the SI prefix, and then tex as in Texas.
Because I noticed you say mut. You don't say mute for references, exclusive references.
There's a couple things that I feel like I say contextually different. Like mute is definitely one. There's a bunch. Like Russ has a bunch of non-word abbreviations.
That is true. It's a struggle when I make videos. I have to pick one and stick to it. And I think I'm switching from immutable reference and mutable reference to exclusive reference and shared reference, even though those don't have the keyword in there.
Alexei is the one that, when we were teaching together, he's the one that got me on that, because he's like, it's better, because one of the things we always had to teach when we were teaching was intermutability, which immediately breaks like the immutable reference and mutable reference thing, because you're passing around an immutable reference to something that you mutate inside of it, like a mutex.
Also because of Rust's like mutability XOR sharing property, you sometimes use mutable references just to enforce some other invariance. You don't actually care about mutating it, but it's just a way to only have one of something. Anyway, that was the title slide. Let's get going. So the thing with ARC Mutex T or ARC read-write log T or things like that is that Rust beginners use a lot of it. Like, we recommend Rust beginners use it to get out of situations and not have to think about lifetimes. And I think that's good. But there comes a time where you want to get rid of them. And I want to talk about some of the alternatives you can use, specifically in the context of my website. My website, fasterthanlie.me, is 18,000 lines of Rust, which I realize actually doesn't sound like a big number, but it is a big number when you have to maintain it, especially when a lot of it is async Rust code and it mixes sync and async. I started writing it 4 years ago, and I've been maintaining it more or less. Like every couple of months I go like, oh, there's new major versions of all the crates I rely on. There's lots of synchronous code and asynchronous code that are mixed up, but that's not today's topic. Short version is just use channels. And it's pretty typical. I do weird things with HTTP. I have HTTP implementation based on IO Uring, which I'm getting funding for, but my website does not use it yet. I am planning on using that, but because my website is web application, it's not directly facing the web. It is actually on Kubernetes with a reverse proxy in front. I don't actually need to care about HTTPS. I don't need to care about HTTP2. I just do plain text HTTP1, and then the reverse proxy in front takes care of everything else. So my plan is to actually use my own HTTP implementation for the reverse proxy as part of Kubernetes. So my website is just Axum on Tokio. I used to use Warp, which is also based on Tokio, but has weird combinators that I didn't like and blew up compilation times. And before that, I used Tide, which is in the async STD ecosystem, let's say, cinematic universe. I don't know if you remember that. Have you ever used Tide and Surf and all that stuff, James?
I'm definitely familiar with it. When I was at Ferris, we were, I think, the one company that funded Async Standard because the people who were working on it worked at Ferris. So I'm familiar with it, but this is before I did a lot of web stuff. But I was wondering if there's a specific French word for dog fooding.
Not that I know of, but I don't really talk about my work in French. That would require going out of the house and talking to other developers, which I do on occasion, but it's mostly an excuse to drink alcohol in a like socially acceptable setting. I don't know.
I was gonna say the same in German. Like my restaurant German is way better than my technical German because all the technical stuff that I do, even locally, everyone's speaking English for. So
exactly.
Yeah, okay, we'll stick with dog fooding.
So Tokio works with a thread pool. What that means is, I want to try and give a short explanation, but I'm in danger of James jumping in and correcting me at any time, which is a good thing. This is why we have two hosts, I suppose. But basically what it means is that you can do work in the background. You can spawn Tokio tasks like you could spawn libstd, libstub threads, for the operating system level threads. But then because those tasks are futures, they can be pulled, they can return saying pull me later when something else has happened. There's nothing saying that the pull function of the future trait of that future will be called from the same thread the next time. So they can move across threads, so they are send by definition, which is a huge headache because there's a lot of things that aren't send or a lot of things that are on sync and you want to hold a reference to them. So that kind of restricts what you do. And specifically in Tokio codebases with that model, you do end up having a lot of arc all the things because you want several tasks to hold a reference to the configuration of your server or a reference to any sort of context, any sort of secrets, anything that like you might want to access in all the workers that service HTTP requests, for example. Tim, do you have any thoughts so far? I'm catching my breath.
No, you nailed it. I was gonna say it's the has to be send is a Tokio specificism, just because they use, like you said, thread stealing executors, where if one worker thread gets really busy, then the other ones can come along and go, I'll take that off your plate. And so stuff doesn't get stalled for a very long time. It's not specific, or it's not required by Rust async, but for Tokio, it's a design decision they make because they looked at a lot of different people. Well, I don't know. I don't need to go into why. But yeah, it's a design decision they made, which is usually pretty reasonable, but it is a point of a lot of half-informed blog posts discussing that decision.
That is true. Every month at least, every couple of weeks, there's a new article saying why Rust async is back. But that is a Tokio specific thing, or like this style executor. The alternative being thread per core, pretty much, where you can imagine a current thread executor per CPU core, however many cores you want to dedicate to the app, and then you explicitly pass things between those. You do message passing, for example, if you want to have a central, API, the old query. If you want to share some state, you usually do message passing. It's a different take on it.
I know Boats has a better name than thread per core, because like Tokio does have a thread per core. It's just a worker thread, and stuff can move between that. I guess like there's like Glomio, I think.
Tokio can have less or more, or
yeah, that's true.
Like it manages the pool automatically, and then it has blocking threads, which is a separate pool and not really a pool because you can have any number of them if you just do a lot of file reads, for example. Anyway, we're trying to get rid of Arc, so let me talk about the alternatives. The first thing is, for example, for my website, there's a config. It's a bunch of JSON-C, I think. It's parsed with Serde. but it never changes. Sometimes you need to reload the config in some code bases because you have a dynamic reloading configuration. In that case, you might want to reach for something like arcswap, which you just told me about, or just remembered about. But in my case, it never ever changes. And it's a long-running program. We need the config from the very start to the very end of the program. So you can just leak it. You just put it on the heap with box new and then do box leak, and then you get a an exclusive reference to it that has lifetime static. And then you can just have that everywhere. You can have a global function that returns a mutable reference to that. And then that's something you don't need to pass everywhere. And you know that except for the first few milliseconds of the program, it is always initialized. The other thing is that as a beginner, you might naturally reach for arc mutex or arc read-write lock, but if you don't actually ever change it, you could just do arc t directly. You don't need to wrap it in some sort of locking thing. It's not a magical combo. They can be used separately. Next up, if your value fits in an atomic, for example, on my website, I have a dev environment and a production environment. That's part of the config, but it's also handy to have in various functions. For example, in development, I show stack traces. In production, I set secure cookies. If it's just a Boolean, you can fit that in a U8. You have an atomic U8 type in the standard library. You can just do that. You don't need an arc. You don't need reference counting at all. It's just a U8 somewhere that you write to and read from atomically. The trick I do want to talk about today is if your global does not change while blocking, then you can use a thread local.
What do you mean by blocking? Do you want to describe to me the use case that you usually use this for? Is it easier to work backwards from reality rather than trying to teach it?
Yes. So let's say you have an async task and you're going to call a blocking function. My use case is I have a bunch of Sass files in my website that define style sheets. They compile down to CSS, and I use a crate called Grass Compiler. Grass Compiler lets you define functions that you can call from Sass, and they end up being Rust functions, so they can evaluate to anything. You can call anything from it. But those Rust functions are freestanding functions. They're not closures. You cannot capture any context. So in my case, that doesn't work. Maybe I need to do a database query to figure out the result of the function call. I need to know whether we're in development or environment. I need to know a lot of things. So I need to pass in context somehow. And I used to do something really dirty, which is I had a process-wide lock. And then when you compile the CSS, it first acquired that lock and then wrote something in a process global and then called the blocking function and then freed it. But then the insight was that even though we're in an async task, as long as we're being polled, as long as we don't yield back to the executor, which we can only do by returning, we own the current thread pretty much. It's ours. There's only two ways we're letting go of it, is that if we return with pending poll or what is the name of the poll pending or poll ready?
Poll pending or poll ready,
right,
or whatever.
Or if we panic and then we unwind. If we abort, that's not our problem. We can't deal with that. So we're holding on to this thread, which means we can set a thread local, and then from the Rust function that's been registered as a Grass extension, we can read that. As long as we clean up things properly and to cover both the return and the panic unwind case, we can just have a guard struct that has a drop implementation that clears the thread local when it's dropped, which happens, either on panic or on return.
So the trick is that you're calling the compilation, which might then call a bunch of other functions, like what is my base address, am I in prod or not? So essentially you need to populate all the settings when you start the compilation, use those values while you're compiling one thing, and then when you're done compiling one thing, which is one big blocking operation, then you just purge the settings cache, which is a thread local, which means you were able to stuff context in, retrieve it back out from the free functions, and then when you're done with the whole compilation, you go, cool, just wipe that away. So the next time I'm compiling something else, I don't get stale cache data from compiling some other page or something like that.
I'm not comfortable calling it a cache. I am comfortable calling it context, which I also believe is what you would call it when Tokyo does it. I have a slide that says implicit context is bad unless I'm the one doing it, which is definitely the way Tokyo does feel. But that's the first bit of the trick, which is not a trick at all. It's just realizing, we have a thread. We can use thread locals, and multiple concurrent invocations of CSS compilation from different tasks are not going to interfere with each other because they are currently being pulled from different threads. So it all works. The next insight is usually you can do that and that's fine, but you still need the thing you put in the thread local to be static, to be owned. So you can have an arg s where s is a struct that has strings, and then you have a reference counted struct with a bunch of strings, or you could like put the struct itself, which has the strings, so you're cloning every string, which might be better for cache locality or something. But I don't want to do that. I don't need to do that, because as long as nothing is changing the thread local while we block, so like we're doing CSS compilation, it only ever reads from the thread local, it never modifies it, and nothing else modifies the thing it's pointing to, then I think it's the only, like one of the only legitimate use cases to cast a lifetime away. If that makes sense.
Oh no, Amos. This got very serious very quickly.
Because hear me out. Casting pointer types and like references and stuff is generally a bad idea. Don't do it. Definitely creating an exclusive reference from a shared reference, so going from like const to mud, is a big no-no, because the compiler will create optimizations because it will assume that you're not mutating anything, and so that is definitely a big no-no. And generally, pointers are unsafe for a reason. There's a lot of ways to get it wrong, but I do believe this is fine. And I have a show code slide here because, ironically, perhaps my website was broken at this time. I was going through a big refactoring. I do believe it is sound.
So, okay, let me make sure I understand this right. So you have sort of like the load context step before you do a compilation, which goes and makes all the database queries and things like that and stores it into either like a stack local stir or a buffer or something like that. And then what you're actually smuggling into the thread local is a pointer to something. So you're pretending that it's static because it's a pointer inside of the thread local, so that whenever anyone accesses it, it's acting, I don't know, bump allocator is not the right word, but something you go, well, it's going to live as long as it lives, and I know that I'm going to manually handle invalidation. So I'm going to go back to the cache metaphor that you don't like, but I'm going to manually invalidate the cache, because when I leave the context of a single thread, so your blocking code is acting like a guard on I'm not going to be moved to another thread, and when you leave that context you wipe the cache or invalidate the cache or the context and things like that. So okay, I'm with you, I think.
So the thread local macro from STD gives you don't see it in the declaration, but it actually wraps whatever type you give it into a local key, which I've become very intimate with as I try to do things across shared objects. So I know what's in there. It's just a struct with a function that gets the address of the thread local. But then the thread local type has a bunch of methods defined. Some of them are only available if the type inside of it is a ref cell. And so I have a ref cell in there. So the actual type is local key, ref cell, option, const pointer to my thing, which is definitely not cursed. And then I have a run with ambient context. It takes a reference to an ambient context, which is definitely not static. It could definitely be freed as soon as this returns. And then it casts that lifetime away by turning it into a raw pointer and puts it in the ambient context thread local, which is very naughty, because if we forget to clear it, we have a dangling pointer. So anyone who references it is going to be in for a surprise. Surprisingly, the run with ambient context function is all safe, because in Rust, creating pointers is not a problem. The referencing them is, which that's always the case. But yeah, there's just a reset on drop struct that has a drop implementation that resets the context back to none. So we have a guard here, then we set it to the reference cast to pointer, and then we call the function, because it takes a function, which is blocking. It cannot yield. You know, people complain about the fact that synchronous function and the asynchronous function in Rust look different. In that case, very good thing. We don't want people to actually return all the way back to Tokyo, because then this scheme would not work at all. And then the other function is with ambient context, which is to actually read whatever's from the thread local. Well, there's a safety comment just above the unsafe block, which says we borrow the thread local. No other thread can drop the context while we're holding a reference to it, which I believe is true if you look at the API that local key provides for ref cell inners. Mm-hmm. If you do with borrow and then with borrow mute somewhere else, it's going to panic. So there is some checking going on.
And you don't have to worry about drop because you're passing a reference in. So the actual owned one is outside of this context. Yes. So you're just passing a pointer in.
Yes.
So when you drop your ref cell containing a pointer, it's not going to call drop on the T, because
yes,
dropping a pointer T doesn't drop T.
Yeah.
Yeah.
So this is safe because, sure, we are taking some lifetime and casting it away into a raw pointer, but then we're immediately casting that again into an even smaller lifetime. So it's okay because the second, like the inner lifetime is smaller than the outer lifetime. And that's the trick. It's fast. You don't have like process-wide logs. It works great. You don't actually have to use arc and clone arcs to just pass context to arbitrary functions. I use that a lot. And then the drawback is, of course, that you have to make sure that it's set before you call function, but it panics friendly, like in a friendly way if you forgot to set it. It's just, you know, the usual debate between do I pass the context down explicitly as a parameter or do I set it to a thread local and hope that it's there? And Tokyo definitely has the same problem.
Gotcha. This is some spicy code, Amos.
I know it is.
I follow what you're doing. And as far as you've explained it, it makes sense. I don't know if I could recommend this. And I wonder what are you gaining here? Like, was mutex contention or ref cells or reference counting too expensive, or is this was this a fevered dive into what can I get away with?
So this is one use case, and it doesn't matter because I only compile CSS when deploying new versions of the site, so that's very rare. But what happens a lot is executing liquid filters. Well, this could be a whole other episode explaining all the crimes I do in Liquid filters.
Sure.
Liquid is a templating engine. Again, you can extend it, and I have a filter that lets you execute arbitrary SQL queries, which, you know, why not talk to the database from the templating language? Why not? And so, yeah, it needs to have a database connection. And again, that's a thread local, and I do the same trick here. And in this case, it is actually required because it's from a thread pool, so we have a reference to it, but we don't own it, and it's going to go back. Like, we have something that's the references to a connection, but it's actually a pooled item connection or something. It's a wrapper type. So in that scenario, it's unavoidable.
Like I said, I think I follow you. Is this I don't know. I don't want to put engineer brain on, because this is a cool thing. And I could what about different ways to solve this problem, but I imagine you've spent quite a bit of time with this.
I'm curious. Come at me. If you have a less cursed solution in mind, I mean, just like the several copies of Tokyo playing nice with each other thing, I wish there was a simpler solution, but...
Yeah, I guess you probably don't want to touch the Sass compilation library to take like a boxed closure or something, because like I've written a bunch of stuff that uses function pointers rather than impl-fn, because especially with closures, you get unnameable types. And for example, like when I was writing a scripting engine, it was very easy to have an array of like, okay, I'm binding this function to this name in my scripting language. So when you type this word, this Rust function gets called. Yes. And that's really easy when everything is an FN, even if it takes context or whatever. That's very easy. But the second that you want to do closures, or actually the other spicy thing that gets you is async functions, because every async function is an unnameable type too. In my scripting language, I ended up having to just have one big match statement that was like all the text keys that you could use, and it mapped them to async functions. But I guess the alternative might be modifying the library to take a boxed closure instead, like a boxed in FN, because then you would be able to like pre-populate all of them with their context and then call them. But that'd probably be I imagine, a fairly invasive change to the library.
It would be. And my strategy to survive in open source now is I'm either going to write my own thing and then tell people that I'm not going to do their weird use case because I wrote it for me, or use something exactly as it is and never require any big change from it because I value the maintainers too much, or fork an existing thing and then, you know, make it do exactly what I need and then, you know, thank the original maintainer profusely but never get up in their business and ask them to change their thing completely just to suit my use case. So in this instance, you know, I have at least two use cases where I don't want to be in charge of maintaining a fork of the Liquid crate. I don't want to be in charge of maintaining a fork of a Sass compiler. So this works, and it's safe, demonstrably. So
spicy, but safe.
I'm happy for you to prove me wrong, or anyone for that matter.
This episode is sponsored by Ladybird Browser. Today, every major web browser is funded or powered by Google's advertising empire. Choice is good, but your only choice is Google. the Ladybird browser wants to do something about this. Ladybird is a brand new browser and web engine written from scratch and free of the influences of big tech. Driven by Web Standards' first approach, Ladybird aims to render the modern web with good performance, stability, and security. From its humble beginnings as an HTML viewer for the Serenity OS Hobby operating system project, Ladybird has since grown into a cross-platform browser supporting Linux, macOS, and other Unix-like systems. In July, Ladybird launched a non-profit to support development and announced a first alpha for early adopters targeting 2026, but you can support the project on GitHub or via donations today. Visit ladybird.org for more information and to join the mailing list. Thanks to Ladybird for sponsoring today's episode.